All right, let's talk about cybersecurity. But for a minute, I want you to forget all the complex code and the super technical jargon. Instead, let's think about it as something, well, something way more epic. The art of defending your very own kingdom. Seriously, just think about that for a second. Your personal data, your bank accounts, your private photos, those are your crown jewels. Your phone and laptop, that's your land, and all your accounts are the gateways into your kingdom. So the big question is, how do you protect it? That's exactly what we're going to map out today, using this whole idea of a digital castle. You know, any good defense starts with one simple thing: knowing exactly what you're protecting. In our digital kingdom, the main goal isn't just about building walls to keep people out. It's really about protecting what's inside, the value, the integrity of our information, our crown jewels. Now, the security of those jewels really boils down to three core ideas, and they're known as the CIA Triad. First up, you've got confidentiality. This one's easy. It's about keeping your secrets secret, making sure only the right people can see your stuff. Think of it as the master lock on the treasury door. Next is integrity. This is all about making sure your data is accurate, that it's trustworthy, that no one snuck in and changed the numbers in your bank account. And finally, there's availability. This one is so important. It means you can actually get to your own data when you need it. A locked treasure chest doesn't do you any good if you can't find the key, right? And this is where the battle lines are really drawn. See, for every principle we're trying to protect with the CIA, there's an attacker trying to do the exact opposite. We can call them DAD. The opposite of confidentiality, that's disclosure, your secrets getting leaked. The enemy of integrity, alteration, someone messing with your data. And the counter to availability, that's destruction. Or maybe you've heard of a denial of service attack. That's like the attackers sending a giant mob to block your castle gates so the real visitors can't get in. It's a constant battle, CIA versus DAD. Okay, so we know what's at stake. Where do we start? Well, you start from the outside and you work your way in. It's time to build the walls of our fortress. And before you even think about digital walls, you gotta think about physical ones. Yeah, I'm serious. Locking down the actual devices, your computer, your phone, the servers in an office, that's a huge first step. And the goals are pretty much what you'd expect for a real castle. You want to deter attackers from even trying. If they do try, you want to delay them. You need to detect them while they're at it, assess what's happening, and then respond. I mean, if someone just walks out the door with your server, it doesn't matter how good your password is. So the digital version of those giant stone walls, that's your firewall. This is your main perimeter defense. It stands right there on the border between your trusted kingdom and the wild, untrusted world of the internet. And just like a guard on the wall, it looks at every single thing trying to get in or out. If something looks shady or it's not on the approved visitor list, boom, it gets blocked. It is your first and probably your most important line of defense. All right, so the walls are up, but a fortress can't be a completely sealed box, right? People and information need to come and go. So now we got to talk about the most critical part: guarding the gates and controlling who gets to come inside. So how do we prove to the guards at the gate that we're allowed in? That process is called authentication, and it usually relies on three types of factors. The first is something you know, your password, a PIN number. The second is something you have, like a physical security key or, your phone getting a text message. And the third is something you are. This is biometrics, like your fingerprint or your face. Now, using more than one of these together, which we call multi-factor authentication, makes your gate way, way more secure. Think about it. A thief might steal your password, but it's a lot harder for them to steal your password and your fingerprint. This whole process of letting someone through the gate is actually a very formal four-step dance. It's called IAAA. First is identification. This is you just claiming who you are, like saying your name. That's your username. Second is authentication. Okay, you say that's who you are, now prove it. That's where you use your password or fingerprint. Third is authorization. So you're inside the walls, now what? What are you actually allowed to do? Maybe you can hang out in the courtyard, but you definitely can't go into the king's chambers. And finally, there's accountability. Everything you do inside is being logged. If something goes wrong, the guards have a scroll that says exactly who did what and when they did it. So, we've built the walls, we're guarding the gates. Now it's time to focus on the most important thing of all: securing the crown jewels themselves, the treasure that's locked deep inside the vaults. You wouldn't store the royal jewels in the same room as the kitchen plates, would you? Of course not. And it's the exact same idea with your data. This is called data classification, and it's just a fancy way of saying you sort your information based on how important it is. Information that anybody can see is public. Internal memos might be confidential, but the real secrets, the launch codes, those are top secret, and each level gets a stronger vault with more guards. But let's say a really clever thief gets past the walls, sneaks by the guards, and breaks into the vault. We've got one last trick up our sleeve: encryption. Think of this like writing all your secrets in a special code. Even if an attacker manages to steal the data, to them it's just a bunch of useless gibberish. It's completely unreadable unless they have the one special key to decipher it. Now, there are basically two main ways to write these secret codes. The first is called symmetric encryption. This is like a locked diary with a single key. You use the same key to lock it and to unlock it. It's fast, it's simple. Asymmetric is a bit more clever. It actually uses two different keys that are mathematically linked. There's a public key that you can give to literally everyone. Think of it as an open padlock. Anyone can use your padlock to lock a message in a box and send it to you, but only you have the one-of-a-kind private key that can actually open it. This also gives you something called non-repudiation, which is just a technical way of saying you can prove a message came from you and only you. Okay, but let's be real for a second. No fortress, no matter how well it's built, is completely unbeatable. Sometimes the attackers are going to get through. The walls are going to fall. So what happens then? How does the kingdom survive a siege and then rebuild? When an attack is actually happening, the absolute #1 priority is something called business continuity. That just means keeping the kingdom's essential services running, even while you're fighting off the invaders. You can't just shut down the entire kingdom. The farmers still need to farm. The bakers still need to bake. You need a plan to keep things going in the middle of a crisis. And then, once the dust has settled, it's time for disaster recovery. So how do you get your kingdom back on its feet? Well, there are three main strategies. A hot site is the top-tier option. It's an exact, real-time mirror of your kingdom, ready to take over in just minutes or hours. A warm site is a step down. It has the basic equipment ready, but it'll take a day or two to get everything back up and running. And a cold site, well, it's basically just an empty room with electricity. It's cheap, but rebuilding from scratch could take you weeks. It all just depends on how fast you absolutely have to get back online. And that brings our entire story full circle. From protecting the crown jewels to building the outer walls, from the guards at the gate to the secret codes in the treasury, we've basically designed our defense. But here's the thing. The attackers, they never rest. This isn't a one-and-done job. It's a constant state of being ready. So I want you to take a hard look at your own digital life. Your castle is under siege right now, whether you realize it or not. The only question left is, are your defenses ready? Thanks for watching.